Hello friends, welcome to the series lecture on network analysis. In this video we are going to discuss about two-port network. I am going to talk about introduction to two-port network. In this video I am going to talk about black box model, various two-port networks that are available, what is the condition on symmetry and reciprocity, all those things I am going to discuss in this video. I'll be having a huge network, so that huge network I'm going to model it as a black box. What is inside the black box or what is the response in the black box I have to find out. So in order to find out what is there inside, I'm going to make use of two power supply. On the port 1, I'm going to give a power supply as V1. The current that is entering into the black box or a port, I'm going to call it as I1. I'm going to excite this port by a source that is V2, and the current that is entering into the port 2, I'm going to call it as I2. Now look at over here, I'm having four variables with me. So what I'm going to do is, two variables I'm going to treat it as an dependent variable and two I'm going to treat it as an independent variable, and then I'm going to check for the response whether in this port it is having a resistive network or inductive network or a capacitive network, or if you are having any active elements in it. All those things I am going to study. So I am having four variables. Out of that I will be varying only two variables at a time, so I can generate six possible combinations. What are those six possible combinations are Z parameter, Y parameter, T parameter, T dash parameter, H parameter and G parameter. This Z parameters is also called as impedance parameter, or it is also called as open circuit parameter. The Y parameter is also called as admittance parameter or short circuit parameter. The transmission parameter or T parameter, it is also called as ABCD parameter. In the case of T dash parameter, or it is also called as A dash, B dash, C dash, D dash parameter, which is quite opposite to that of T parameter. Your G parameter is a replica of H parameter. This H parameter you are going to use in order to model BJTs. Now what do you mean by Z parameter? In the case of Z parameters, V1 and V2 are dependent variables, I1 and I2 are independent variables. These things are very important. These mathematical equations you have to remember for each and every two-port parameter. In the case of Y parameter, you are going to take I1 and I2 as dependent variable and V1 and V2 as independent variable. In the case of T parameters or ABCD parameters, V1 and I1 are dependent, V2 and I2 as independent variable I am going to assume. Now look at over here, the currents are entering into the port, but in the case of T parameter, this I2 direction will be outwards, because this one they have derived with the help of transmission line. And H parameter, if I am talking, I am going to take V1 and I2 as dependent variable and I1 and V2 as an independent variable. If I am talking about T dash parameter, it is V2 and I2, which is given by A dash times of V1 minus B dash times of I1. Similarly, I2 is given by C dash times of V1 minus D dash times of I1. If I am talking about G parameter, it is V2 and I1. V2 is given by G11 times of I2 plus G12 times of V1. And I2 is given by G21 times of I2 plus G22 times of V1. If you are preparing for any competitive exams, you have to remember the mathematical equation for Z parameter, Y parameter, T parameter and H parameter. Hardly you can expect the questions based on T dash parameter and G parameter. But if you are preparing for GATE exams, Z, Y, T and H parameters are more than enough. Let us talk about symmetricity as well as reciprocal. Now look at over here, what do you mean by Z11? Z11 means the port to port impedance I have to measure. Z11 means the input port impedance, I am going to call it as Z11. If I am writing Z12, that is nothing but from port 1 to port 2, what is that impedance? I am going to denote by Z12. If I am writing Z21, that is nothing but From port 2, if I am looking through port 1, what is the impedance from this end is denoted by Z21. If I am writing Z22, it is nothing but port 2 impedance. Similarly, I need to talk about admittance as well as transmission line parameters, H parameters also. In the case of Z parameters, the symmetric condition should be Z11 should be equals to Z22. But the reciprocal condition is Z12 should be equals to Z21. Then only it is reciprocal. But if I am talking about Y parameters, Y11 should be equals to Y22. Also, the reciprocal condition is same as Z parameters, nothing but Y12 equals to Y21. Next parameter is T parameters or ABCD parameter. In the case of symmetric condition, that is A equals to D. The reciprocal condition is AD minus BC, which is equals to 1. But if I am talking about H parameter, it is H11 H22 minus H12 H21, which should be equals to 1 for symmetrical condition, and for reciprocal condition H12 should be equals to minus H21. This is very important. If I am talking about G parameter over here, it should be G12 should be equals to minus G21. This is the condition for symmetricity as well as reciprocal condition. So in this video, I have given a glimpse on two-port network. I have talked about black box model also. I have discussed 6 parameters. Out of that, 4 are very important. I have discussed mathematical equations also, and I have discussed the symmetrical condition as well as a reciprocal condition. In the next video, I will be talking about Z parameters, conversion of Z parameters to other parameters. All those things I will be discussing in next video. Thank you for being on my channel. Please like the video, share this video with your friends, and subscribe to my channel, Craving Gyan. All the best for your competitive exams. Thank you.